Okay. Today is September 9th. Okay. I think also, all right. I'm going to be checking notes. So I will you know what? I might actually start that on like Thursday. So make sure you have your notes with you. So I'll be checking notes on Thursday and Friday. So that's a good idea. You need to write the example 1 and the directions. That's what I look. Okay. Yeah. Not really. You should write the date. That's always useful. That's why I write it. Okay, here we go. What number squared gives you 25? 5 and negative 5, right? Yeah, negative 5 quantity squared. Negative 5 times negative 5 equals 25. So 5 and negative 5. What do you need to do for number 2? Add 36. Yeah, so it looks like this one. So x squared equals 36. And then you can say, hey, what number squared gives you 36? Plus or minus 6. Yeah, 6 and negative 6. So 2 solutions. And that's really important because this power, that's called the degree of the function. We'll actually learn more about this later. But that power tells us a lot about the number of answers. So we have 2 solutions because this is a power of 2 function. Okay, that is the degree, and it tells you a lot of information. So my question to you is, what number squared gives you negative 25? Imaginary 5, which is exactly correct. Okay, so there is no real number. No real number gives us, that we can square gives us negative 25. 5 squared is positive 25. Negative 5 squared is positive 25. There's no real number that gives us an answer of negative 25. And because there's no real number, and by the way, a real number is any number you can think of. Okay. Big negative, positive, and negative, any number you can think of is a real number. So, because of this problem, the guys way back when said, hey, we need to be able to solve these. And so in order to find the solution to this, they said we need a whole new number system. And that whole new number system is the complex numbers. And a complex number, the complex number system includes imaginary numbers. All right. So now what we have is, you guys know our real number system. Just everything you think of: positive 1, negative 5, 1/2, pi, radical 2. These are all the real numbers that exist. Okay, all of them. But now we have this whole other system that it actually does overlap a little bit, I guess I would say. The imaginary numbers. The imaginary number system. And these 2 things put together, now we have the complex number system. SYSTEM. Okay, so our complex number system is these 2 groups of numbers put together now. So we have this whole nother set of imaginary numbers that we get to include now with our answers. In addition to our real numbers. So they're real numbers, and then there's imaginary ones. Do you get that? They're real, like real, okay? Meaning they're there, you can see them, and then imaginary numbers aren't really there. We can't really see them. It's our happy little imaginary friend, okay? Eric. Yes, so the two together make the complex number system. So you can read more about that in your book, but I'm not going to go into it right now. We'll talk more about complex numbers later. So here's what they did. they defined the complex number I. So this is the important part. I, for imaginary, is the square root of -1. This is the definition of an imaginary number. I is the square root of -1. That's it. Now, I can do some other stuff to that. If I know that I is equal to the square root of -1, you should definitely write that down. If I know that I is the square root of -1, then I can also do some operations with that. So let's say I want to square both sides. It's an equation. I can do that. I'm allowed. So I being squared is I squared. But what is the square root of -1 squared? -1. The square root and the square sort of undo one another, and what are we left with? -1. Well, that's very interesting. So it turns out that when we take an imaginary number and we square it, what do we get? -1. We're back in the real number land. Hey, that's kind of cool. All right. All right. So there's more about this sort of pattern going on in your homework. So you'll do some more with that. We're going to today, it's kind of a nice day. We're simplifying complex numbers. It turns out to be really easy. So here we go. Example 1, add or subtract as indicated. They might say write your answer in standard form. So I'm going to write down what standard form is. Standard form. Form, F-O-R-M. Sorry, standard form. Oh, wait, that's not any better. Standard form is A plus BI, where A is a real number, and then BI is the imaginary portion of it. It's kind of I. So that's standard form of a complex number, the real part plus the imaginary part. Guess what? I's work just like X's. They're like terms. So we're combining like terms, and that's all we're doing. All right, so this says I have one complex number and I want to add this other complex number. Do I need those parentheses? They're not really helping me out. So all we're doing is combining like terms. 1/2 plus 2/3. What do we need there? Common denominator. So it's going to be 3/6 plus 4/6. Okay, and that's going to give me what? 7/6. Okay. And then I'm going to add together my imaginary parts here. 3/4 I plus 1/5 I. What do we need there? Common denominator. What's the common denominator? 20. Okay, so that's going to be times by 5. So 15/20 I plus 4/20 I. So I'm just combining my like terms here. What is 15/20 I plus 4/20 I? It's 19/20 I, and that's it. 7/6 is fine. Yeah. Okay. So here we are subtracting, big subtraction sign. We are subtracting some complex numbers. So in this case, these parentheses are actually going to be helpful for us. What do we need to do with this subtraction sign? Yeah, distribute it. Very good. So we have 3 plus, we say I radical 2. Minus a -4 becomes plus 4. And then minus a -3 I radical 2 becomes plus 3i. I love my door. It's awesome. 3i radical 2. You'll notice where they placed the I. Your book goes into quite a bit of detail about notation. The common practice, we could say radical 2I. That is also fine. There's nothing wrong with that. These two things are multiplied together, and so it doesn't matter what order you put them in. But we usually write it I radical 2 just so we don't have any notation confusion. For instance, I wouldn't want to write radical 2I where the I is under the radical. So, and that's the problem. Usually students have pretty bad notation and they extend the radical too far. And so we can't tell, is the I under the radical? Was it a mistake? Because this is very different and we wouldn't see that. Okay? So traditionally, we're going to pull the I out in front. You can see here, this is 3 times I times the radical 2. And again, that's just sort of the traditional way we would write. Numbers first, then letters, then a radical. Again. All right, so just combining like terms here. 3 and 4 is 7. And this is 1 I radical 2 plus 3 I's radical 2, which is going to give you 4 I's radical 2. 4 I's, huh? Funny. Okay. Anything to get a laugh when you're in math class. All right. Questions on that? That was easy, right? Super easy. Combining like terms. That's all we're doing. Okay, this is a little bit harder. So this is how we simplify when we have negatives under square roots. And it's really, really important that we simplify using I first. So anytime you have a radical and inside the radical you have a negative, we have to be pretty careful. So this, you'll notice, is these are only square roots, first of all. This I, remember, is the square root of -1. It doesn't really apply if it's a 4th root or an 8th root or only for square root. Okay. All right, so here, what I'm going to do for the square root of -12 is I like to break square roots apart, and I see this as a -1 times 12. And I can break apart 12 into what times what? 4 times 3. And I chose 4 because 4 is a perfect square. And so when I'm simplifying these roots, these square roots now, when I have a -1, well, this is really the square root of -1 times the square root of 4 times the square root of 3. I can break that giant radical up into a bunch of little radicals. What is the square root of -1? I. What is the square root of 4? 2. And can I do anything with the square root of 3? No, it stays. You could leave it like this, but usually we're going to write 2I radical 3, and that's the final answer. Now, that was a whole lot of steps. Do you have to do it in that many steps? No. If you got a negative under your square root, you pull out a 9. And you simplify the root the same way you have been doing. Okay. So here again, I'm going to do this in a billion steps just to make sure. So I'm going to break apart -24 as -1 times what? 4 times 6. And again, a giant radical can be split up into the square root of -1, the square root of 4, and the square root of 6. What is the square root of -1? I. And the square root of 4? 2. And I can't do anything with radical 6. So how would I write this in sort of a nice way? Yeah, 6I radical 6. Very good. Hard or easy? Good. So this is just a new definition of what I is and what is I? Radical -1. This is what you must learn today. Radical -1. Do you have any questions for me? That's it? Nice.